Hello. Here's a solution to problem 8.9.10 in the Collaborative Statistics textbook. The question is trying to estimate a percentage of drivers who always buckle up before riding in a car. First question, when we're designing the study, not actually doing the study yet, but designing it, want to be 95% confident, and the estimate is within 3%, maximum margin of error. So I gave you all in my 244 class a program, sample size calc. Those of you out there in the statistics world, if you're not using technology, I'll show you that in a second. If you're in my 244 class and you run sample size calc, that's your TI program you're probably going to want to use. Your confidence is going to be set at 95, which you can put, oops, put that a different color. Your confidence is at 95, which you can put in as a whole number, for sure. Your margin of error is not. I discovered a coding discrepancy, so I want you guys putting in margins of error as decimals. So that's 3%, 0.03. And when you press enter, it will come back with 1,068. That's your minimum that you would need to evaluate at 95% confidence with no more than 3% margin of error. Those of you out in stat world, if you are cranking these by hand, your sample size, if you've seen the derivation formula for sample size, it's your critical value squared over your margin of error squared desired times 0.25. So all you do is you back substitute in the values you need for here. So for Z, you'd use 1.96, which is roughly 2 standard deviations. For the margin of error, and this is why the decimal is so important, it's 0.03 quantity squared, and that's all times 0.25, and you'll end up with 1,068 from there. I'm making an assumption here, and I'm assuming that the authors wanted me to make this assumption that we are not assuming anything about previous studies, no previous values of p hat or q hat. That's why we're using the 0.25. So either way, your sample size desired is going to be 1,060. That's the magic value. 95% confidence, 3% maximum margin of error, always 1,068. If you're calculating by hand, one quick note, this value will come up to 1,067 and some change. When you're calculating these by hand, you always round up. You never round down. Just add a caveat for convention, and also because if you round down, you actually either lose confidence a little bit or you increase the desired or the maximum allowable margin of error. So you round up and take care of that. More important, I think, to realize is not either of those two things, but more important is that if you want 1,000 people in a survey and you're going to survey them, say, by mail, you better mail out 10,000 to maybe get 1,000 back. Just keep that in mind. Part B says if it was later determined that it was important to be more than 95% confident and you knew and a new survey was commissioned, how would that affect the maximum number, or the minimum number, excuse me, you would need to survey? So here's your minimum number from before. So what's cool about this, you can think about this purely logically or mathematically, formulaically. So if you need to be more confident, it stands to reason you'd have to ask more people. Right? That kind of makes sense. I mean, if you ask fewer people, you're going to be less confident in your answer. I think that goes without saying in life in general, right? In life in general. So kind of conversationally and logically, we'd have to ask more people. It didn't tell us how much more confident, so I'm not going to worry about that. But if you look mathematically, assuming that we still want a 3% margin of error, this is going to stay the same. That's going to stay the same. But that is going to increase with confidence, right? Because that's the critical value on the bell curve. The more confident you are, the more standard errors you're going to allow in the sampling distribution, which means the further out you have to go. So knowing that, that has to get larger. And since that's in the numerator of this fraction, that's going to make this value here go up. So there's two ways of looking at part B for exercise 10.